Okay, so we are going to look into charge, its properties, and the electric force along with electric field. So first, let us look into the charge. What is charge? It is a property of any object due to which it creates or experiences electric field around it. So if there is a body which has some charge, then if you place this object in space, it will modify the space around it in such a way that if any other charge comes near to this, then this charge which has just entered into the electric field, it will be either attracted or it will be repelled away from this main source charge. So it is the property which creates electric field around it. Electric field around it. That is called charge. But how this property appears in any body? So this property is of two types. This is of two types. One is called inherent property, and another is called acquired property. So we are talking about the charge, property of charge. Inherent property means there are certain objects which has charge from the time it is born. Means nature has given it, nature has already given it a kind of charge. For example, electron. Electron has inherent charge. Proton has inherent charge. Okay. So by the time when they come into existence, they have this charge. So we will say that electron and proton has inherent charge, whereas most of the objects are neutral by birth. Okay, they are neutral by birth, but we will do something. We will do something to charge them. That type of charge which is acquired it is coming into second category. Is it clear?
Yeah.
Okay.
What would be like an example of an acquired charge?
We will say it. We will say it because example of acquired charge means most of the items are neutral only, and by method of charging, we create charge on them. Okay.
Okay.
See, now here important is how to charge them. So charging means not the mobile charging. Here charging means electrostatic charging. And in electrostatics, charging means addition or removal of electrons from the object. Addition or removal of the electrons. Let me write here. Addition or removal of the electrons from the body. That is called charging. Now, by birth, any object has equal number of protons and equal number of electrons. So initially, everyone has initial number of protons and initial number of electrons. So that's why they are neutral. But now let's say we have from this object, we have taken out some electrons. If we have taken out some electrons, then this object will have more number of protons than number of electrons. So we will say that this has become positively charged body. Okay. So if you take out the electron, if you take out some electrons from the object, then we will say that we have positively charged the body. And opposite is if we give some excess electron, if we give some extra electron from outside, then it will become negatively charged body because number of electrons will be more than number of protons. Number of electrons will be more than number of protons. This is how we charge. So see, charging means simply by any method we have to add or remove the electrons from it. We cannot remove or add proton, because proton is residing inside the nucleus, and to remove the proton or to add the proton, that means you have to blast the nucleus. That means you have to carry on nuclear reaction. So obviously we do not want that. So we have to give some electron, or we have to take out some electrons in for charging the body. Is it clear?
Yeah, I understand.
Okay. Now quickly, can you tell me how do we charge one object? What do we do?
When we say it's charging, we mean the addition or removal of electrons from the body. And
Yes.
initially, when an object is neutral, it has the same number of protons as it does electrons. But then when we take away electrons, since we're taking away the negative charge, it becomes positively charged. And when
Yes.
we add electrons, since we're adding more negative charge, it becomes negatively charged.
Perfect. Now, how do we add or remove the electrons? So there are certain methods. So now we will look into methods of charging. Although there are many methods, we have to focus only on only three types. Okay, by the way, what are the methods? So we have charging by friction. It is also called triboelectricity. Triboelectricity. Another method is called charging by conduction. Another one is charging by induction. Apart from that, we have another method, charging by photoelectric effect, charging by thermionic emission, and charging by field effect. What are these? We will quickly look into this. In charging by friction, we rub two objects together. And in this process, electron from one object will move to the other object. So one object will become positively charged, other object will become negatively charged. In conduction, we we uh, we either we touch I will either we will touch the object together, or we will make some kind of contact between them, and it can, and in this process some charging will take place. We will discuss more about it. In induction, we will not touch the objects, but we will bring them close to each other, and then induction effect will take place. So these three we will focus on. Uh, Last three, although these are the methods, but these are not that much popular, and they are usually not in our syllabus. So photoelectric effect means we hit the object, we hit any metal surface by some uh, light, like a beam of photons, and some electron may come out of it. If electron will come out of it, that means it will become positively charged. Similarly, thermionic emission means we will supply heat. We will heat one object. We will heat one metal surface, one metallic body, to that extent that electron will come out of it. So that is also a method of charging. And in field effect, we apply strong electric field. But last three method, we are not going to see any further. We will focus on first three. Okay, please note it down. Then we will go to friction methods of charging.
Yeah, I have written down.
Fine. Now we will look into the charging by friction. Charging by friction. So, okay. In charging by friction, what will happen is we will take two uncharged bodies and let us take this as A and this as B. They are neutral. Now we are going to rub them together. While rubbing, what will happen? There is a chance that some electron from one object may go to the other object. And why they will so? Because one of this object will be more electron affinity. So let's say A has more electron affinity than B. What is electron affinity? Electron affinity is the like you can say attraction towards the electron. So if A is more, if A has, let's say, as an example, let's say A has more electron affinity than B, then what will happen is when we rub them together, since A has more electron affinity, then the electrons will move towards A. So this one will become negatively charged body and this one will become positively charged body. Okay. See, net charge remains same because just you imagine that you imagine that this is inside a closed box and we are not allowing any electron to pass through this boundary. Now think that, let's say number of electron initially was 50 here and here number of electrons was initially, let's say 100. Now what is the total number of electrons initially? It is 150. Now let's say 10 electrons moves from B to A. Now number of electrons in A becomes 60, whereas number of electrons in B becomes 90. Here also we can say that that final number of electrons of this system is still 150. It is just the electron distribution has taken place. Okay.
Yeah.
Right. But although this friction, this method is very, very popular among the nature because lightning also produces this electricity. You will get a lot more examples of electricity or triboelectricity in nature, but we are unable to commercialize it because of the property of actually controlling the number of electrons. How much electron will transfer from each other, that we don't know. Okay. But this type of method is very it is seen in nature. Okay, now let us look into the charging by conduction. Before going further, can you tell me whatever you have understood about charging by friction?
Charging by friction is when you essentially rub two objects against each other, and this leads to a change in the amount of electrons each object has, and thus creates charge. And this is because one object has a higher electron affinity and pulls the electrons towards itself. And the net electrons stay the same throughout the process.
Good. Now we will look into the charging by conduction. So, charging by conduction. So here one object must be, one body must be charged. In previous situation, in previous method, both body were neutral. But when you do the charging by conduction, one body must be charged and the other body will be neutral. Okay, generally we take this one. Another body will be neutral. And we want to charge this neutral body. So what we will do is, let's say this is one object, this is another object, A and B. Let's say A has some charge. So we will connect them. The moment we will connect them, charge will move from high potential to low potential body. So let's say it has high potential and it has low potential. So when you connect them with some metallic wire or conducting wire, then charge will move from high potential to low potential object till their potential becomes equal. In this process, this body B, which was initially neutral, it will gain some electrons. Okay. So here also charge will be different, and here also charge will be different. Okay, this is called charging by conduction. We will see some examples for this when we look into the electric potential concept. Then we will see some numerical problems related to charging by conduction. Right now it is not required. Okay.
Yeah.
Now we will look into charging by induction. So charging by induction method, by induction process. So here also one object must be charged body and another object will be neutral. So let's say A object is positively charged and B is neutral. What we will do is we will place them very close to each other, but we will not touch them. Okay. Now when they are placed very close to each other, there is electron redistribution takes place inside B. Because the body A is positively charged body, all the electron cloud will move together. That means we can say that here there will be positive cloud. Say proton does not move, but electron will move. So that means the deficiency of the region where electron is not there, we can say that positive cloud is there. So here we can see that negative charges will be facing towards this body A and the positive charge will be repelled away. Then one important step in this charging is you have to do the earthing. That is, you have to ground the object B. And this you have to do only for a fraction of a second. So you just touch this body B with the ground and immediately remove it. When this body B was grounded, then Earth has a property of neutralizing the charge. Means Earth does not like charge. It will always try to neutralize the body by making the potential zero. Here, just for this session, you just keep in mind that Earth will try to neutralize the body. So since here plus is there, Earth will supply some electrons to it so that this part will be neutralized. And Earth will also try to bring this excess electron towards Earth. It will also try to pull this excess electron towards Earth. But since these electrons are held strongly by this body, ground cannot do anything with this negative cloud. And so it means that grounding can neutralize only the positive cloud. And this will be done in a fraction of a second. So you just ground it and then you immediately cut it. So when you cut it, what will happen is when you remove this one, when you remove this earthing, we will see that only negative charge, only negative charge is there. then you remove this object also. Then what will happen? These electrons, which were initially crowded, they will separate away from each other due to repulsion, and this body B will be negatively charged body. So you see, when we have initially when we have taken this body B, it was neutral, but at the end of this induction process, this body B has become negatively charged body. Understood?
Yeah, okay.
Okay. Now let us see another example. Same type, so that it will be okay. So let us take one body which is negatively charged body, and we have one neutral body here. Now we want to charge this neutral body. So this is A, this is B. What we will do, we will place them close to each other, but we will not touch them. So here positive cloud will be attracted and negative cloud will be repelled away. Then you do the earthing. You do the earthing and immediately you remove it. Remember, when you do the earthing, don't remove body A. Otherwise, everything will be neutralized by the earth. So while you ground it, while you touch the earth, while you do the grounding, A must be there. Okay. So when you do the grounding, this negative part, this negative cloud will vanish. This negative cloud will vanish. So now after doing this, after neutralizing the negative part, then you remove this A towards this side. So what will happen? This, all the positive charge will ultimately place their way. They will be separated from each other as far as possible to minimize the repulsion. So we got the positively charged body. So that means to charge the body by induction, we have to take oppositely charged body from the beginning. Is it okay?
Yeah, I get it.
Okay, good. So we have seen three types of charging method: charging by friction, charging by conduction, and charging by induction. Okay. Okay. Can you quickly explain me quickly in 1 minute how do we do the charging by induction? Let us take, so I'm giving you this scenario. Let's say we have one object. We have one object which is positively charged body, and we have one neutral body. We want to charge it. So tell me, what is the steps? What are the steps that we want to do?
Bring both the objects really close to each other, but not like no contact. And this would lead to the side that's closer to the positives being negatively charged and the other side being positively charged. And then you would do earthing where you bring it close to the earth, and then since it's going to try to neutralize the body, it would take away the positive cloud by adding electrons. And then after that, you would cut that connection and take away the first body, and then the second one will be negative.
Perfect. Perfect. Very good. Now, and what was the method of conduction?
Conduction is when one body is charged and the other is neutral, and then you connect them through a wire or touch them somehow, and then the electrons in the higher potential object move into the electron with the lower potential until it's even.
Until their potential becomes equal. Okay. In that process, charge distribution will take place. So we will charge the other neutral body in this way. In fact, conduction can be done by using charged bodies also, but usually we take one as charged and another is uncharged. Okay. Yes. Now, having said this, let us look into the properties of charge. So Let us look into the properties of charge. Okay. So although there are many properties, we will see some of the basic one. First of all, charge is a scalar quantity, so no need to worry about its direction. It has only magnitude. Then it is of two types: positive charge body, negative charge body. Positive charge body means number of protons must be greater than number of electrons. So there is a deficiency of electrons here. Deficiency of electrons in the body. Whereas negatively charged body means number of electron is more than number of proton. And so we will say that here we have excess of electrons. Then charge can be added algebraically. So we can do the algebraic addition. We can do the algebraic addition. What does it mean? That we will simply, we can say that if any object has a charge of 20 coulomb, then we can add plus 5 coulomb to it. So it will become 25 coulomb. So there is no other method of adding or subtracting. It is simply algebraic operation. Okay. Then charge is conserved. So we will see this conservation of charge after this slide. Okay, so conservation of charge. Remember, we have to look into this conservation of charge. See, individually charge can be created, charge can be destroyed, but while the creation and while the destruction of charge, you are taking out the electron or you are giving the electron from some other body, right? So, but if you consider the other body also in the system, then you can say that charge is conserved. So, we will say that net charge of an isolated system remains same. Isolated means you are not allowing the electrons to exit or electrons to cross through the boundary. For example, let us make one hypothetical boundary like this, and we have two objects. Let's say we have two objects, A and B. Now you are rubbing it together. So if you are rubbing it together, okay, maybe some electron, let's say 10 electron is moving from B to A, fine. But within this boundary, total number of electrons remains same. So net charge remains same. In fact, net charge of entire universe is same. Entire universe, because what is happening? One object is giving charge to another object, but total charge remains same. Okay, this is conservation of charge. Then we will look into this, that charge is always associated with mass. Always associated with mass. What does it mean? Because if any object is neutral, fine, we will say that number of proton is equal to number of electron. But if we say that one object is charged object, that means, let's say if we say that it is positively charged, that means number of proton is greater than number of electron. This excess, since we have some excess of proton, that means it will have definitely some mass. We cannot say that there is no mass associated with it. But reverse may or may not be true. Means it is not necessary that mass is always associated with charge, but charge is always associated with mass. Is it okay? Understood?
Yeah, I get it.
Okay. Now another one. Charge is invariant. Charge is invariant. What does it mean? Invariant means it is independent of reference frame. Now, in simple technical terms, charge does not depend upon motion. It is independent of motion of the object. independent of motion of the object. Now, why this is important? Because mass is variant. Remember that mass changes with motion. Mass is variant. Mass changes with, in fact, mass increases with speed. So mass is variant, whereas charge is invariant. We can take one example like this. Let's say we have one object. Initially, it was at rest. So let's say mass is 5 kg and charge is 5 coulomb. So initially it was at rest. Now it starts moving. During the motion, if we calculate the mass and if we calculate the charge, interestingly, we will get that mass is more than 5 kg. It is during the motion. And whereas charge will remain same because charge do not depend on motion. Charge will remain same. Is it okay?
Yeah.
Okay. Now we will look into some interesting property which leads to electromagnetism. That is, if we have any charge at rest produces electric field around it. In fact, electrostatic field around it. Electrostatic field around it. This is the beautiful property. Charge at rest will produce electrostatic field around it. Whereas charge in uniform motion, not accelerated. So if one charge is moving with constant speed in same direction, that is, if the charge is moving with uniform velocity, then this charge will produce electrostatic field also plus magnetic field also. It will produce both. And if the charge is moving with non-uniform velocity, so charge in non-uniform motion, it will create electric field also, magnetic field also, and also it will radiate electromagnetic waves. That means, typically speaking, it should lose energy in the form of electromagnetic waves. This is the property of charge. Okay, is it okay?
Mm-hmm.
So we have seen some important properties of charge. There are other properties also, but these are some of the important properties. Another important property is charge is quantized. Charge is quantized. What does it mean? It means that any object can be given charge only through the integral multiple of electron, because charging means adding or removal of electrons. So you cannot remove part of the electron. If you are doing it, if you are adding either 1 electron, 2 electron, but not half electron, not 1/4 of electron, right? So it means that charge is quantized. So that's why there is very important formula, Q is equal to NE. It should be plus minus NE, because you can either make the negative charge or you can make positive charge. So here N refers to integer. Here N refers to integer and E refers to charge on an electron. Charge on an electron whose value is negative 1.6 times 10 to the power negative 19 coulomb. This is the electronic charge. It is the minimum possible charge right now, till now, as per our study.
Mm-hmm.
Okay?
Yeah.
So have you noted all of them?
Yeah.
Can you quickly, in 2 minutes, can you quickly brief about all the properties quickly?
Some properties of charge is that it's scalar And when it's positive, there's a lack of electrons. When it's negative, there's an excess amount of electrons. And you always do algebraic addition to find the charge. And charge is all conserved, meaning that the net charge in an isolated system is always the same. And then charge is always associated with mass because of the protons.
Yes.
And then charge is invariant, meaning it's not dependent on the motion of the object. Then charges, when charge is at rest, it creates an electrostatic field. When charge is moving in uniform velocity, there's an electrostatic and a magnetic field formed. When charge is moving in a non-uniform motion, there's a electrostatic, magnetic, and electromagnetic waves formed. And then charge is complex, meaning that it will always be an integer number.
Perfect. Very good. These are the properties of charge. So we have seen properties of charge, method of charging, and what do we mean by charge? Everything we have discussed. Now, what will happen if one charge comes near to another charge? There will be a force of attraction or force of repulsion, and that is what it is called Coulomb's law. This we have already done earlier also, Coulomb's law. Okay, so if we look into this, if we have two charges Q1 and Q2 separated by certain distance r, then these two charges will either attract each other or repel each other with a force which follows Coulomb's law. It says that the electrostatic force between these two charges is directly proportional to the product of the two charges and inversely proportional to square of the distance between them. And if we combine these two, we will get force is directly proportional to Q1, Q2 by R squared. Now, if you remove this proportionality factor, you have to include one constant. So we will write F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R squared. This is the constant which we have substituted instead of this factor. Now, what is this 1 by 4 pi epsilon naught? It is called electrostatic constant. So we can write that force of attraction or force of repulsion between two charges is given by 1 over 4 pi epsilon naught Q1 Q2 by R squared. Here 1 over 4 pi epsilon naught is sometimes we write it as K. Okay, but later on we will use K as dielectric constant, but for the time being we are using this to be K, and it is equal to 9 times 10 to the power 9. And this epsilon naught, it is called absolute electrical permittivity in vacuum, whose value is about 8.85 times 10 to the power minus 12. Okay. Now, henceforth, we will simply take 1 by 4 pi epsilon naught as K. So we can say that force of attraction or repulsion between the two charges is given by K Q1 Q2 by R squared. So if you increase the magnitude of any of the charges or both the charges, this force, this electrostatic force will increase. Similarly, if you increase the distance between them, this electrostatic force magnitude will decrease. So this is one important formula, and it is called Coulomb's law. So F is equal to K Q1 Q2 by R squared. Okay. So now what we will do, we will do some numerical problems related to this Coulomb's law. Okay. Yes. Thank you.